Greetings, curious humans. Welcome back to the SciBot GPT channel. Today, we're embarking on an exhilarating journey through the cosmos as we delve into the captivating story of the New Horizons probe. In this video, we're going to uncover the astonishing tale of how humanity's thirst for discovery propelled a small spacecraft on an epic voyage to the outer reaches of our solar system and beyond. From its conception to its groundbreaking encounters with Pluto and the Kuiper Belt, the New Horizons mission has rewritten the books on what we thought we knew about these distant celestial bodies. So buckle up, because over the next few minutes, we'll explore the cutting-edge technology that powers the probe, the challenges its mission faced, and the awe-inspiring discoveries it has made along the way. Get ready to embark on a cosmic adventure that will leave you marveling at the wonders of space and the boundless spirit of exploration. But before we dive into the depths of space, remember to hit that subscribe button and ring the notification bell so you don't miss out on any of our thrilling explorations of the universe. Without further ado, let's launch into the mesmerizing story of the New Horizons probe. The New Horizons Space Probe, a remarkable creation of the Johns Hopkins University Applied Physics Laboratory, APL, and the Southwest Research Institute, SWRI, was launched in 2006 as part of NASA's New Frontiers program. Led by the visionary Alan Stern, its primary objective was to conduct a flyby study of the Pluto system in 2015, while also planning a secondary mission to explore one or more Kuiper Belt objects, KBOs, in the following decade. This mission eventually focused on the study of the Kuiper Belt object 486,958 Arrokoth. The launch on January 19, 2006, marked a historic moment as New Horizons soared into an Earth and solar escape trajectory via an Atlas V rocket from Cape Canaveral Space Force Station. With a staggering speed of around 16.26 kilometers per second, 10.10 miles per second, it became the fastest man-made object ever launched from Earth. After a brief encounter with asteroid 132,524 APL, the spacecraft journeyed towards Jupiter, utilizing the planet's gravity to gain speed and refine its scientific capabilities. New Horizons' closest approach to Jupiter occurred on February 28, 2007, providing crucial data about the giant planet's atmosphere, moons, and magnetosphere. For much of its post-Jupiter voyage, the probe entered hibernation mode to conserve its systems, punctuated by periodic checkouts. In December 2014, New Horizons emerged from hibernation in preparation for its monumental Pluto encounter. On July 14, 2015, at 11:49 Universal Time Coordinated, it made history by flying just 12,500 kilometers (7,800 miles) above the surface of Pluto, becoming the first spacecraft to explore the enigmatic dwarf planet. Having completed its Pluto flyby, New Horizons charted a course for Kuiper Belt object 486,958 Arrokoth, previously known as Ultima Thule. On January 1, 2019, it achieved another groundbreaking flyby, this time capturing insights about the distant object when it was positioned 43.4 astronomical units from the Sun. Additionally, New Horizons contributed to the confirmation of a hydrogen wall at the outer reaches of the solar system, reinforcing the findings of the Voyager spacecraft from 1992. In August 1992, JPL scientist Robert Stale contacted Pluto discoverer Clyde Tombaugh, seeking permission to send a mission to Pluto. Tombaugh granted his approval, though humorously mentioning the challenges of the journey. This conversation initiated the chain of events that eventually led to the New Horizons mission. Stamatios Tom Cremigis, a prominent figure in the Applied Physics Laboratory Space Division, collaborated with Alan Stern in December 2000 to form the New Horizons team. Stern, appointed as the project's principal investigator, was deemed the embodiment of the Pluto mission. The project built upon Stern's prior work on Pluto 350 and drew extensively from the Pluto Kuiper Express team. New Horizons emerged as one of 5 proposals officially submitted to NASA. It advanced to become one of the 2 finalists chosen for a 3-month concept study in June 2001. The competing finalist, Posse, Pluto and Outer Solar System Explorer, led by Larry W. Esposito of the University of Colorado Boulder, garnered support from JPL, Lockheed Martin, and the University of California. However, APL had a strategic advantage. Supported by the Pluto Kuiper Express developers at Goddard Space Flight Center and Stanford University, APL had recently succeeded in the development of Near Shoemaker, a mission that achieved orbit around Eros. This achievement lent credibility to APL's capabilities. In November 2001, New Horizons was officially granted funding under the New Frontiers program. Nonetheless, the change in NASA leadership led by Sean O'Keefe cast doubt on the mission's future by excluding it from NASA's budget for 2003. Ed Weiler, NASA's Associate Administrator for the Science Mission Directorate, urged Stern to advocate for New Horizons funding to secure a place in the Planetary Science Decadal Survey. This survey, reflecting the scientific community's priorities, placed New Horizons at the forefront, surpassing even missions to the Moon and Jupiter. The 2003 to 2013 Planetary Science Decadal Survey solidified New Horizons as the highest priority medium-sized project, marking a significant achievement for Stern's campaign. Securing funding was a turning point, enabling Stern's team to commence construction of the spacecraft and its instruments. The mission was set to launch in January 2006 with a projected arrival at Pluto in 2015. Alice Bowman assumed the role of Mission Operations Manager. In summary, the New Horizons mission's inception can be traced back to a phone call seeking permission from Pluto's discoverer. The collaborative efforts of leaders like Cremigis and Stern, combined with strategic advantages and successful lobbying, paved the way for New Horizons to become a high-priority mission, securing funding and ultimately leading to its historic journey to Pluto and beyond. The New Horizons mission aims to unravel the mysteries surrounding the formation of the Plutonian system, the Kuiper Belt, and the early solar system's evolution. This spacecraft is a treasure trove of data on Pluto and its moons, focusing on their atmospheres, surfaces, interiors, and surroundings. The mission also encompasses the study of various objects within the Kuiper Belt. A remarkable feat is that New Horizons has collected 5,000 times more data about Pluto than Mariner did about Mars. The mission raises critical questions such as the composition and behavior of Pluto's atmosphere, the appearance of its surface, the existence of significant geological structures, and the interaction between solar wind particles and Pluto's atmosphere. The scientific goals are to map surface compositions of Pluto and Charon, characterize geologies and morphologies of Pluto and Charon, study the neutral atmosphere of Pluto and its escape rate, investigate whether Charon has an atmosphere, chart surface temperatures on Pluto and Charon, search for additional satellites or rings around Pluto, extend similar investigations to one or more Kuiper Belt objects. New Horizons design and construction follow the example of the Ulysses spacecraft, featuring a radioisotope thermoelectric generator, RTG, and dish enclosed within a triangular structure. The spacecraft is larger than necessary to serve as radiation shielding, protecting its electronics. Its black interior balances temperature through radiative heat transfer, while the outer shell is insulated for heat retention. The spacecraft employs both spin-stabilized and three-axis stabilized modes, utilizing hydrazine monopropellant for propulsion and attitude control. Communications occur via X-band, with a data rate of around 1 kilobit per second at Pluto's distance. The Deep Space Network dishes relay commands once New Horizons is beyond Jupiter, with dual modular redundancy transmitters and receivers. The spacecraft carries a cylindrical RTG for power, containing plutonium-238 oxide pellets, and it uses dual redundant 12-watt traveling wave tube amplifiers to amplify its downlink signal. 2 star cameras and miniature inertial measurement units aid in spacecraft attitude determination. The mission has encountered safing events, sending the spacecraft into safe mode on 2 occasions, but it successfully recovered. New Horizons scientific instrument data is stored in solid-state memory, then transmitted to Earth. Data storage is facilitated by 2 low-power solid-state recorders, each holding up to 8 gigabytes. Due to the vast distance from Pluto and the Kuiper Belt, only 1 buffer load at each encounter can be saved for transmission. The mission's innovative approach and meticulous engineering have positioned New Horizons as an invaluable asset in our quest to uncover the mysteries of our solar system's outer reaches. The New Horizons mission underwent various stages, from its launch preparations to its encounters and observations in space. Launched on January 19, 2006, from Cape Canaveral Air Force Station, the spacecraft experienced initial delays due to technical issues and weather conditions. The launch was dedicated to the memory of Daniel Sarachan, a significant figure in space travel. Trajectory corrections were conducted in January and March 2006, refining the spacecraft's path. It crossed Mars orbit in April 2006 and conducted its first in-flight tests of onboard science instruments in February 2006. Additionally, the spacecraft unexpectedly encountered the asteroid 132524 APL in June 2006, allowing for observations and testing of instrument capabilities. The first images of Pluto were captured in September 2006 during a test of the Long-Range Reconnaissance Imager, LORI, validating the spacecraft's ability to track distant targets. The spacecraft then focused on a gravity assist maneuver using Jupiter in early 2007. The Jupiter encounter, which occurred in February 2007, served as a shakedown for the upcoming Pluto encounter. New Horizons received valuable data about Jupiter's atmospheric conditions, storm activity, its rings, and its magnetosphere. Despite being distant from Jupiter's Galilean moons, New Horizons observed and analyzed Io's active volcanoes, gaining insights into their eruptions and plumes. The spacecraft also examined Callisto's surface using infrared spectroscopy and refined the orbit solutions of minor moons like Amalthea. Overall, these stages in the mission marked important milestones as New Horizons gathered crucial data, tested its instruments, and honed its approach for its ultimate destination, Pluto in the Kuiper Belt. After its successful flyby of Jupiter, New Horizons entered a phase of its journey towards Pluto where it spent most of its time in hibernation mode. This operational approach aimed to conserve energy and extend the lifespan of onboard systems. During hibernation, redundant components and guidance systems were shut down, allowing the deep space network to be used for other missions. The spacecraft's onboard computer remained active, periodically transmitting a signal back to Earth to report its status, a green code indicating normal operation or a red code if assistance was required. To maintain functionality, New Horizons was periodically activated for about 2 months each year. This allowed for system checks, calibration of instruments, and software updates. The first hibernation mode cycle commenced on June 28, 2007, followed by subsequent cycles in 2008, 2009, and 2014. This operational strategy aimed to ensure the spacecraft's health and readiness for its ultimate encounter with Pluto. During its journey, New Horizons encountered the orbits of Saturn and Uranus in 2008 and 2011, respectively, further demonstrating its trajectory accuracy. Concerns arose about potential hazards from debris and dust around Pluto, especially after the discovery of new moons in its system, Kerberos and Styx. The team's simulations and observations indicated that the risk of collision with debris was minimal, and contingency plans were devised to address any potential hazards. In 2012, while in hibernation, New Horizons began gathering scientific data from specific instruments. This expanded phase of data collection aimed to provide valuable insights into the heliosphere. These activities were carefully planned to ensure that the additional data gathering did not compromise the spacecraft's energy, memory, or fuel resources. As New Horizons approached Pluto, it started to actively observe and photograph its target. A series of trajectory correction maneuvers were performed to fine-tune its path for a precise flyby. The spacecraft's instruments captured images of Pluto and its moon Charon separately for the first time in 2013. Further trajectory corrections were executed in preparation for the upcoming flyby. In early 2015, distant encounter operations with Pluto began, and the spacecraft's instruments captured images and data of its target. These observations helped to refine its trajectory for the flyby. The team released images of Pluto and its moon Charon, showcasing their growing detail as the spacecraft approached. In the lead-up to the flyby, New Horizons encountered 2 smaller moons of Pluto, Nix and Hydra, which were captured in images and helped refine the mission's navigation. However, the journey was not without challenges. In July 2015, a software anomaly caused New Horizons to enter a safe mode, temporarily suspending its scientific observations. NASA engineers identified and resolved the issue, allowing the spacecraft to resume its mission without significant impact on its objectives. Throughout this period, New Horizons traversed the vast expanse of the outer solar system, diligently collecting data, performing course corrections, and overcoming technical obstacles. Its journey marked the culmination of years of preparation, leading up to the historic encounter with Pluto and its moons. The closest approach of the New Horizons spacecraft to Pluto occurred at 11:49 Universal Time Coordinated on July 14, 2015, at an astonishingly close range of 12,472 kilometers (7,750 miles) from the surface of Pluto and 13,658 kilometers (8,487 miles) from its center. Telemetry data confirming the success of the flyby and the spacecraft's health was received on Earth from the vicinity of the Pluto system on July 15, 2015, at 0:52 and 37 seconds Universal Time Coordinated. This followed 22 hours of planned radio silence during which the spacecraft was pointed towards the Pluto system. Mission managers had calculated a 1 in 10,000 chance of debris causing damage to the probe or its communication systems during the flyby, which could have prevented the transmission of data back to Earth. The initial details of the encounter were received the next day, but the complete data set was downloaded over a span of just over 15 months via the spacecraft's 2 kbps data downlink. The analysis of this data set continues to this day as of 2021. The objectives of the New Horizons mission were categorized into primary, secondary, and tertiary priorities. The primary objectives were essential and had to be met, while secondary objectives were anticipated but not mandatory. Tertiary objectives were desired and could have been bypassed in favor of higher priority objectives. These objectives encompassed a wide range of scientific goals, including characterizing the geology, morphology, and chemistry of Pluto and Charon, studying their atmospheres, mapping their surfaces, analyzing time variability, and searching for additional moons or rings. The flyby itself was a meticulously planned operation. New Horizons came within an incredibly close distance of Pluto, passing within 12,500 kilometers (7,800 miles), while also coming as close as 28,800 kilometers (17,900 miles) to Charon, one of Pluto's moons. The spacecraft's relative velocity at closest approach was 13.78 kilometers per second, 49,600 kilometers per hour, 30,800 miles per hour. The imaging strategy was carefully orchestrated, with long-range imaging capturing Pluto and Charon at a resolution of up to 40 kilometers (25 miles), enabling comprehensive coverage of their surfaces. Close-range imaging was performed twice daily to detect any surface changes. Instruments on board New Horizons carried out a multitude of observations during the flyby. Alice characterized the atmosphere, SWAP and Pepsi studied the high atmosphere and its interactions with the solar wind, VBSDC searched for dust and meteoroid collision rates, and REX performed active and passive radio science, allowing precise measurements of Pluto's diameter, atmospheric density, and composition. Additionally, the spacecraft's communication signal was used to evaluate Pluto's mass distribution by analyzing the Doppler shift. The flyby provided unprecedented views of Pluto and its moons, with images showcasing details on the surface, geological features, and even night-side observations. The spacecraft's observations led to discoveries such as the small size and reflective nature of Kerberos, one of Pluto's moons, which defied initial predictions. In essence, the New Horizons spacecraft's flyby of Pluto was a remarkable success, achieving its mission objectives and providing a wealth of data that continues to be analyzed and studied by scientists around the world. Following the successful flyby of Pluto, New Horizons reported its good health and on-track flight path in July 2015. The spacecraft had recorded science data from the Pluto-Charon system, and the immediate task was to start transmitting the collected 6.25 gigabytes of information back to Earth. Due to the vast distance of approximately 4.5 light-hours, 3 billion kilometers, between New Horizons and Earth, the data transmission rate was limited to only 1 to 2 kilobits per second. By March 2016, approximately 9 months after the flyby, New Horizons had transmitted half of the data, and the transmission was successfully completed on October 25, 2016. The data included observations from the Ralph/LASA imager, among other instruments, providing valuable insights into the Pluto-Charon system. By November 2018, New Horizons was at a distance of 43 astronomical units from the Sun, heading toward the constellation Sagittarius at a velocity of 14.10 kilometers per second relative to the Sun. It remained operational and fully functional, despite its great distance from Earth. On April 17, 2021, the spacecraft reached a distance of 50 astronomical units from the Sun, continuing to operate and send back valuable data. In terms of its mission extension, the New Horizons team secured funding for an extended mission through 2021, known as the Kuiper Belt Extended Mission, KEM. During this phase, the spacecraft performed a close flyby of the Kuiper Belt Object 486958 Arrokoth, previously known as 486958, 2014 MU-69 or Ultima Thule, on January 1, 2019. Additionally, New Horizons conducted observations of other Kuiper Belt objects, KBOs, and continued to study the gas, dust, and plasma composition of the Kuiper Belt as part of its extended mission objectives. The selection of 486,958 Arrokoth as the flyby target was based on its suitable orbital parameters and estimated fuel requirements. The spacecraft's observations also included distant images of other KBOs, such as Quaoar and Haumea, from considerable distances away. Overall, the extended mission provided a valuable opportunity to further explore the distant Kuiper Belt region and expand our understanding of these icy bodies beyond the orbit of Neptune. The Kuiper Belt Extended Mission, KEM, of New Horizons included a flyby of the Kuiper Belt Object, KBO, known as 486958 Arrokoth, formerly designated as 486958, 2014 MU-69 or Ultima Thule. The science objectives of this flyby aim to characterize the geology, morphology, and surface composition of Arrokoth, similar to the Pluto flyby. Additionally, the mission sought to map surface topography, measure surface temperature, search for signs of activity such as a coma, and investigate the presence of satellites or rings around the object. The spacecraft's trajectory was adjusted through a series of targeting maneuvers to bring it within 3,500 kilometers of Arrokoth, allowing for high-resolution imaging. The approach phase began in August 2018, with New Horizons making its first detection of Arrokoth in August 2018 from a distance of 107 million miles. The actual flyby occurred on January 1, 2019, at a speed of 51,500 kilometers per hour and within 3,500 kilometers of Arrokoth. Most of the science data was collected within 48 hours of the closest approach. Following the flyby, preliminary high-priority data was sent to Earth, and New Horizons prepared to send the remainder of its data back. Data download was expected to take around 20 months due to the limited data transmission rate. The spacecraft continued to function and engage in other scientific observations, such as measuring the cosmic optical background. New Horizons' extended mission continued to explore the Kuiper Belt, with potential plans for additional flybys in the 2020s if suitable KBOs are found within its trajectory. The spacecraft remained operational, with enough power to continue its operations into the 2030s. The mission provided valuable insights into the distant regions of our solar system and contributed to our understanding of KBOs and their characteristics. And there you have it, fellow space enthusiasts, a mesmerizing journey through the remarkable achievements of the New Horizons probe. From its awe-inspiring launch to its daring encounter with Pluto and beyond, we've delved into the incredible feats and scientific discoveries this intrepid spacecraft has brought us. As we wrap up this exploration, let's take a moment to reflect on the profound impact of New Horizons. With its groundbreaking insights into the mysteries of Pluto's surface, its revelation of the stunning diversity within the Kuiper Belt, and its continuous transmission of data back to Earth, this mission exemplifies the unyielding spirit of human curiosity and exploration. Remember, space exploration is a testament to our innate desire to explore the unknown, to push the boundaries of our understanding, and to unveil the secrets of the universe. The New Horizons probe stands as a beacon of inspiration, reminding us that there are no limits to what we can achieve when we collaborate, innovate, and strive for knowledge. But the journey doesn't end here. As we eagerly await future missions that will further unravel the mysteries of our cosmic neighborhood, let's celebrate the remarkable achievements of New Horizons and the dedicated scientists, engineers, and visionaries who made it all possible. Don't forget to like and subscribe to stay updated on the latest discoveries in space exploration, and feel free to share your thoughts and questions in the comments below. This is SciBot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.